It's mainly used for processing people, but can also be used for chopping down trees. Welcome back to my garage. We're still in the eternal struggle against my home-built 50cc two-stroke engine. Currently we're trying to go back to basics, running it with a normal reed valve. Everything normal, no blowers, no nitromethane, no rotary exhaust valves, no nothing. Just a normal two-stroke engine, normal. And as so many times before, we're struggling with getting over that hump in the power band before the pipe kicks in. The hump where the pipe is fighting the engine, pushing mixture back in when it's supposed to suck it out, and vice versa. I have a plan. This is an axe. It's mainly used for processing people, but can also be used for chopping down trees. To be efficient, the business end needs a certain shape, or rather to be within a range of certain shapes. This quite beefy specimen is meant to be accelerated up to the highest speed possible to dig deeply into flesh or wood. It not only needs to dig deep, it also needs to crack the wood fibers each side of it so that chips will break out. And it's nice if it doesn't stick too bad, so you can pull it out easily and take another chunk. This profile has to have a certain shape to achieve this. It needs to be thin and parallel enough to dig deep, but not so thin that it will break on impact, and not too parallel, because then it will stick. It needs to be wedge shaped enough to not stick, and also to force the wood fibers on each side apart so that chips will break out. In the axe world, dinner plate sized chips is a good thing. The larger the better, fewer swings to cut the tree in half. This is a knife. Yes, I call that a knife. It's meant for stabbing people and carving wood. It's not swung by maximum force into a tree. It's used for carving and stabbing. It has a much thinner profile and a more fragile edge. It needs that to cut well without all that axe force. If we put this profile on the axe head, it will probably just break on the first swing. At least get really dull and the edge will just break up. If we put the axe profile on the knife, it will become really inefficient at carving. Conclusion, an axe needs axe geometry to work well and not break. A knife needs knife geometry to work well without the weight and force from the axe swing behind it. An axe cannot have knife geometry because it will just break and suck at breaking wood fibers apart and stick really badly. A knife can have axe geometry but will be horrible at its job. A two-stroke engine with an expansion pipe has a power curve like this. The earmarked assets for replacing the blackboard is still there, just haven't gotten around to replacing it yet. You can picture this first part as knife territory. This second part where all the power is, that's the axe territory. I've designed everything in this engine to work great in the axe territory, and thereby it really sucks in the knife territory. It's probably more horrible than most engines in the knife territory. Remember how if you make an axe more knife-like, it becomes worse at being an axe. In the same way, if I tune the engine to work great in knife territory, if I try tuning the engine to work great here, it will work worse here. You can't have both at the same time. We need a clutch. With a clutch, we can get past this area under absolutely no load and only run the engine under load in this area. This is how you normally do it in a bike. You feather the clutch until it can be fully disengaged and you won't drop out of the power band. If you encounter a hill and you drop out of the power band, you gear down. You're never running a two-stroke engine outside the axe area, the power band. You shouldn't, at least not in racing. Different in daily driving, but we're not talking daily driving here. There's no clutch in my dyno system, because I'm stupid. The whole drivetrain, including the retarder, is hooked up to the engine all the time, from idle enough, far away from how you do things in a normal two-stroke engine. I've talked about mounting a manual clutch several times, but I never got to it. There is actually a centrifugal clutch on here, but it's locked up because it was not working properly, slipping. That was over a year ago. We could make an exhaust valve or mount a trombone pipe or have an additional volume here which could be valved and opened under the power band. Stuff like that. But it's not necessary because we're going to run a clutch when this is mounted in a bike. We won't need the knife face, only the axe face. Clutch it is. I was going to start designing something for this to work. It's a Derby 50cc engine clutch. It's engaged from the outside with this lever. Make up some kind of framework around this so it could engage this. But it's not meant to be run dry. There's no bearings or anything here meant to be run dry. Then I went to a friend's garage and borrowed this Speedway bike dry clutch, and it's perfect for the application. So I can just mount this to the dyno frame, run a chain from this to the existing shaft, use that as a jack shaft. All we have to do is machine down the sprocket part of the clutch basket and mount my existing sprocket to this, and make some mounts and a chain and a sprocket, and with not much work. Before we take this apart and start working, let's start the engine, but now with the chain to the retarder removed. Should be the same as with the clutch engaged. Up until now, we've literally started the bike in gear and then tried revving it up to the power band. Now we're starting it in neutral, like you would do in a bike. There's no clutch here, but when the clutch is mounted, we'll start it in neutral, bring it up to proper RPM, and then disengage the clutch. Feather it into gear. As you can see, it's revving just fine, and now the car is hopelessly out of tune because we've tried to tune it for working at low RPM off the pipe and also on RPM on the pipe. But when we need to tune it perfectly for high RPM, it'll just bring itself past the humps and all that because there's no load on the engine. And then we'll engage the clutch like you would do in a bike. This is what engages the clutch. There's a little ball bearing in here and then a rod from the other side, and this is the lever that pushes on that rod, pushing the plates apart. This is how I locked the centrifugal clutch, which I couldn't get to work properly. It was either slipping too much or not slipping early enough. And I tried different clutches and different springs, and should have tried much heavier shoes, lighter springs, something like that. As this is spinning much slower than what these scooter clutches are meant for, they're completely out of tune. And now we're going manual. We won't have to worry about tuning the clutch. I'll machine away the existing sprocket, then countersink just a millimeter down, just to not remove too much material from to keep as much material as possible, just enough to have this register properly. I'll drill mounting holes and use countersink bolts from the inside. was getting ready to clamp this down and start machining, but then realized it's too large for my mill by just a tiny bit. I can't do this in a mill. This really is a lathe operation anyway, which brings me to my other problem. I've only got this 3-jaw chuck for my mill, and the jaws are non-reversible, and this is my only set of jaws, which means I can't hold this. This has to end. I need to get a new chuck, preferably one of the 4-jaw variety with independent jaws. It's proven hard to find a 4-jaw chuck that will fit directly onto the faceplate or backing plate of my lathe. I probably have to modify it. I'll do some more searching. Maybe I'll find options that will fit directly so that I can still use the existing 3-jaw chuck. But now I'm on my way back to my friend's garage, my friend with the clutch, because he's got a bigger lathe. This looks weird. It's the first time I'm filming with autofocus and auto ISO. I usually have everything set to manual, but this might be more convenient when I'm out and about. I need to pick up more of these short bolts. I've only got shorter ones or 2 long ones. When I press on this, or when the wire is pulling on this, it pushes this plunger out. That in turn pushes on the clutch plate. Time to make a little bracket. Replaced my old travel tripod with a much longer one. Certainly is a workout holding the camera this far away, but that's what you have to do when you're filming with a far too long a focal length for vlogging purposes. I'm on my way to pick up a chain and stuff for the Dyno clutch. Back from a little shopping trip. I've picked up a chain. Thank you Alf Grorud Motor for the great price. Picked up some short enough bolts of this variety. Picked up a taper lock sprocket from the mail. This is a 10B sprocket, same pitch and roller diameter as a 530 chain. The sprocket sitting on the clutch is a 520 sprocket. 520, 530 and 10B has the same pitch and roller diameter, but 530 and 10B are much wider, which means I'll have to turn down this sprocket a little bit. There's very little room between the nuts for the mounting bolts on the sprocket and the chain, so that's why I'm not going with a 530 chain. If you're wondering why I'm suddenly doing all this vlogging, it's cause there's a trip to Germany to meet some really interesting people in the pipeline. I need to practice my vlogging game. Well, I want to do some interviews and film around people and stuff, which is something I'm not really comfortable doing. I need to practice. leave this loose and we'll make this work, and then we'll set the clearance with a spacer here. I forgot about this thing, which was supposed to sit here. I'm running out of time if I want this edited and uploaded today. We're pretty much ready. We'll need some guards and stuff, but everything is hooked up. I'll quickly warm up the coolant and we'll see how the clutch behaves. It'll probably need some adjustment. We don't have time for that now. Let's hope it works as intended. As a clutch. Game plan, fire up the starter motor with the clutch engaged. Disengage the clutch to start the engine, and then re-engage the clutch to have it spin in neutral. And then try clutching it out in the power band, like you would do in a bike. First, let's see if the clutch is working by just spinning the starter motor. Perfect. I'll put on some air protection and turn on the exhaust extraction. Then the first test. Success! It works exactly as intended. Perfect. Unfortunately, as I said, I haven't got time to do more testing now. And we'll need to hook up an RPM sensor for the dyno to work again. I was taking RPM from the Ignitec ignition unit earlier. Now I'm not running that Ignitec ignition unit, and there's no RPM out on this unit. Nor is there an RPM output on the other unit, which I'm going to run. We'll need to dial back timing now to be in the safe zone and test it with a light, and then start tuning properly in the power band. Disregard the stuff below the power band, like it's supposed to be done. See you next time.